Okay, today we are talking about the commutative property of multiplication, which means that if you have 1 times 8 is the same as 8 times 1. If you have 2 times 4, it's the same as 4 times 2. We can also call this the turnaround rule for multiplication. So those are the same thing. The commutative property is the same as the turnaround rule. So we're going to kind of explore that a little bit today. The first one is right here. It says, roll a die twice to get 2 factors. Sketch an array using the 2 factors and record a number sentence to match. Switch the factors and record an array and number sentence to match. So if you have a dice at home, go ahead and get it, a 6-sided dice. If not, I can just tell you the numbers that we're going to use. So the first one is done for us. They roll a 3 and a 4. So the first array, they made 3 rows of 4, and the second array, they make 4 rows of 3. And that's how you write it. 3 times 4 equals 12, and 4 times 3 equals 12. Now we're going to do a couple together here. If you have your journal, it is on page 88, and you can follow me in your journal, or you can do the slide 3 with us right now. Let's go ahead and go to the next screen where we come to the factors that we're using. If you have a dice, let's pretend I rolled a dice. And my first number was a 2, so go ahead and write a 2. And my next number I get on my dice is a 6. All right, let's do an array. For those that have the slides, you have these dots up here that you can use. If you don't, just use your pencil and make X's on these circles. So let's do the first array. Let's do, whoops, sorry, I need to take this off. I don't want to be writing on it. So I need to get that off. I'm not writing anymore. I don't want to write. So let's see if this will work now. Yep, there we go. 1. Let's do 2 rows of 6 this first time. 3, 4, 5, 6, 2, 3, 4, 5, 6. So our number sentence down here, now I'll write that down, is 2 rows times 6 is how many? How many dots do we have up there? You can count by 2s 6 times, or you can count the dots. If you did that correctly, you should have gotten 12. And then we're going to do the same thing with the second one. Of course, I got to take this off first. And we're going to do, this time, we're going to do 6 rows. 1, oh, I have to pull it all the way over here. 2, 3, 4, 5, come on down, 6. It's not a very straight line, but you got the idea. And then 1, 2, 3, 4, 5, So this time I did 6 rows of 2. So my number sentence will be a little different. We're going to write 6 times 2 equals 12. This is called the turnaround rule. 2 times 6 equals 12, and 6 times 2 equals 12. Okay, let's do one more on the next screen. Let's make our factors this time. Let's say we roll a 5. So I'll write that down here, a 5. And let's say we roll a 3. So those are our factors. Now we're going to make an array with 5 times 3. So I'm going to get off the pen so we don't mark that. Okay, so let's do 5 rows of 3 the first time. 1, 2, 3, 4, 5. And we're going to put 3 in each row. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oops, leave that there. 1, 2, and 3. And the last row, if I can get this. 1, 2, and 3. So our number sentence would be, okay, we have 5 rows times 3. 5 rows of 3. How many dots do we have? You can count by 5s 3 times, or you can count the dots, and you should have gotten 15 as your answer. Now let's make our second array. This time we're going to do 3 rows of 5. So we're going to make 1, 2, 3, and then we're going to put 5 in each row. So 2, 3, 4, 5, 2, 3, 4. Remember, I hope you're doing this with me. You should not just be watching me, but you should be doing it on your paper, in your journal, or on your screen as well, and following me and doing what I'm doing. So we're doing this together. And then the last one is there. So now this would, our number sentence would be, we have 3 rows times 5, and of course the answer is going to be the same. And this is called our turnaround rule, or the commutative property of multiplication. The question is, what do you notice about each pair of arrays? In all those arrays that we did, what do we notice? They have, so what do we notice about each pair of arrays? They have the same answer. The are turned. You notice about each pair of the arrays, they have the same answer. The factors are turned around, but the answer is the same. That is why we call it the turnaround rule for multiplication.